Everyone, and welcome back to our discussion for today. So this is the continuation of the six trigonometric ratios. Last time we discussed about finding the ratio of a right triangle without the given angle, and we also discussed what would happen. What will no, what would happen if the angle is not special. So now how about we find the angle, whether if it's special or not? So how do we find the angle in a given right triangle? So here you will be using inverse trigonometric functions. These functions are very useful in terms of finding the angle. So let me give you, for example, if I have y is equal to sine theta, all right? And you want to find the angle here. You want to find the angle here, okay? Because that is our goal. That is your goal. So what will happen is that we will put the word sine here, excluding the input or the theta here. So we will have sine. Then we will have like a negative exponent of 1, right? Then we have no, not open parenthesis, but we have a y as an input to the inverse function of sine, then is equal to theta. Okay? By the way, just like what I told you right now, this looks like a negative one, but not exactly. Because there's a two difference. So this one is not the same as this one. Okay? They are not the same. Not the same. This one is basically the inverse of sine function. Okay? uh, Commonly, we describe it as arc sine. We can represent this one as arc sine of y. Okay? So this one, in other words, this is arc sine of theta. Okay? This one is just the what? Reciprocal of sine theta. So it's 1 all over sine theta. So these are different. Okay? They're not the same. They're different. So yeah, you get the idea on how would we get the angle, which is by using the inverse trigonometric functions. Okay, so let me give you some examples. Okay, we will be applying all the six trigonometric ratios. Remember that for your sine, we have the ratio of opposite all over hypotenuse. And now let's find the angle. So what should we do? We put the sign beside here. So we will have theta is equal to sine and put like a negative 1 here. Then O all over H will be the input of this one. So there we go. So this is arc sine. We can rewrite it this way. There we go. So arc sine. This is basically the inverse function of sine. Okay? So you're going to use this one. But can we use other trigonometric functions such as cosine and tangent? Yes, you can, right? However, be careful of your ratio because remember, in every trigonometric ratio, they have their own ratio. So here we have cosine theta is equal to adjacent all over hypotenuse. So let's find the angle. So put cosine here. The result would be theta is equal to arc cosine of adjacent all over hypotenuse. Okay? Now, lastly, we have for tangent theta. Okay? So we have O all over A. So again, put the word tangent to the right, leaving the input alone, which is the theta. So we will have arc tangent of O all over A. Alright? So these are the three inverse trigonometric functions, although there are three more. Remember, we have cosecant function or cosecant function, secant function, and cotangent function. We have those three functions, all right? We can find its inverse trigonometric functions. It's possible, okay? But for now, I want you to never forget this one. I suggest you should take a picture of this one, right? This and this and this. Yeah, take a picture of this one or put it down on your notes because we're going to use this one later. Now, how about for the other trigonometric ratios, right? So I have a picture here. The source is this one. Wait, there you go. The source is this one, all right? Don't worry, I'll be sending it to the description, all right? So going back, these are like some of the basic trigonometric functions here. So for now, we're going to focus on on few of these uh, trigonometric functions, or rather equivalents, which is this one, this one, this one. Uh, yeah, until there. The rest, just like these, we will discuss this one soon. Okay? Because after this video about finding the angle, we will have like a practice video, like from I think from getting the ratio of a right triangle, and then uh, we have a given hypotenuse and angles, how will you find the other sides? And lastly, this one, finding the angle. After that practice video, we're going to discuss the properties of the trigonometric function. Because after that, what do you call this one? We're going to discuss one of the important application of right triangle trigonometry. Okay? Then after that, yeah, overall practice, then uh, what does it about? I think it's uh it's about other triangle. But yeah, for now let's focus on this one. All right, let's not waste time. So we're going to focus on these three trigonometric e- what do you call this one? Trigonometric equivalents. Okay, so remember that we have cosecant theta, right? Cosecant theta is basically hypotenuse all over O, right? So if you want to get the inverse trigonometric function, you can do the same thing here. Like put the word cosecant here. So we will have theta is equal to arc cosecant of h all over O. Now, yeah, you can still rewrite this as arc, then cosecant, then h all over O. You can do that, right? You still can. Okay. But you see, if you have your own scientific calculator, which we're going to use it later, uh, the calculator only gives three inverse trigonometric functions. And those are arcsine, arccosine, and arctangent. So there's no such thing as arccosecant in your scientific calculator, unless there is, or it is given in your scientific calculator. So what are we going to do? Okay, is there thing that we're going to do in order for us to find the arc cosecant? Yes, we can do that. All right. Remember your cosecant theta, it's the reciprocal of sine theta. So in other words, cosecant theta is equal to 1 all over sine theta. Okay. So here, let me just rewrite it here. Cosecant theta is equal to 1 all over sine theta. What I'm gonna do here is I will switch the position of sine theta and cosecant theta. So what I will have is sine theta is equal to 1 all over cosecant theta. Okay. Then Remember that cosecant theta, it's what? H all over O, right? So this is 1 all over H all over O. Okay? Oh, wait, no, no, no. Yeah, correct, correct. Then, since we're looking for the theta, we're going to put sine to the right side. Hence, we will have theta is equal to arc sine of 1 all over H all over O. Okay? Basically, if you want to find arc cosecant, and you don't have let's just say, a button in your scientific calculator to find arc cosecant, just use this one instead. Okay? Just use this one instead. All right? So, arc cosec arc cosecant of H all over O is just the same as arc sine of 1 all over H all over O. They're just the same. Okay? And we will do it to the other two trigonometric functions as well. Okay? Because arc secant theta and arc cotangent theta are also not given in your scientific calculator commonly, unless, once again, it's given in your calculator. So, how do we find arc secant theta? Okay, so that we can use it in your scientific calculator. So remember that secant theta is equal to the ratio of hypotenuse to the adjacent. And you want to find the theta here, so you put the secant here. So you will have theta is equal to arc secant of H all over A. All right? So again, we will find its equivalent for us to apply it in the scientific calculator. Remember again that secant theta is the reciprocal of cosine, which is 1 all over cosine theta. So what we're going to do is we will switch the position of secant theta and cosine theta. So we will have cosine theta is equal to 1 all over secant theta. Okay? Remember that secant theta is just the same as H all over A. So we will have 1 all over H all over A. That's it. And now that our goal, once again, is to find the angle, we will put cosine here. So what we will have is theta is equal to arc cosine of 1 all over H all over A. That's it. So, in other words, if you want to find arc secant of H all over A, but it's impossible for you to do so since it's not given in your scientific calculator, use this one instead. Okay? I mean, use this one instead. This one. Okay? This one. Use this one. All right? And lastly, for your cotangent theta, we will do the same thing as well. All right? So the way how I will be discussing this one, I'll just go straight to the point. Because the way how I derive the inverse trigonometric functions of secant and cosecant is just the same as how I will be deriving the inverse trigonometric function of cotangent theta. Okay? So remember that cotangent theta is equal to the ratio of adjacent to opposites. So if you want to find the angle with the use of cotangent, you will have arc cotangent of A all over O. Or uh, you can use this one instead, which is arc tangent of 1 all over A all over all over O. That's it. Okay? So if in your calculator you have this one, then you're lucky. But if you don't have, just use this one. Okay, just use this one. Now, in here, I've given you all of the inverse trigonometric functions, right? Now, let me tell you, all of those trigonometric and inverse trigonometric functions they should have the same answer. Okay? Again, all of those inverse trigonometric functions we have, all of them should result into the same answer. Like what will be the answer of arcsine? That will be also the answer for the arccosine, arctangent, and the other inverse trigonometric functions. Remember that, okay? So let's apply to one of the example here. Let's start with the, wait, no, not start, but let's try finding the angle in a simple right triangle, like the simple one. So I forgot to put a right angle here. So we have a hypotenuse of 5 units. This is 4 units long, and this is 3 units long. Okay? So let's find the inverse trigonometric, no, not the inverse. Let's find the angle here. All right, let's find the angle here. Right? Let's find that. So let's try first with the sine theta. Okay? So remember that if you're going to use sine function and you're going to find the angle, you will have theta. Wait. It's better this way. Wait. Remember that sine theta is equal to the ratio of opposite to hypotenuse. Okay? So put the, what's that again? Put the sine here. You will have theta is equal to arc sine of O all over H. Now we substitute. Your O is your opposite side. 3 is your opposite side because remember that the opposite side is non-adjacent side, or it's not adjacent to the angle, or in other words, it's not beside with the angle here. So we will have 3 all over your hypotenuse, which is your 5. So now let's use our calculator. So arc sine of 3 all over 5, you will have approximately at 2 decimal place, this is 36.87 degrees. 36.87 degrees. Okay? Now, how about we try cosine? Okay, let's try cosine theta. Okay? So this one, it's adjacent all over hypotenuse. So what to do again? You put cosine to the right, so you will have arc cosine of adjacent all over hypotenuse. That's it. Okay. So here, your adjacent, it's your 4, since it's beside to the angle. So we have arc cosine of 4 all over your hypotenuse 5. So this one, arc cosine, wait. So anyways, arc cosine of 4 all over 5 will give you also approximately 36.87 degrees. Okay? So you see, so far they're the same. Now let's try another trigonometric equation here. Tangent theta. Oh, wait. By the way, guys, I actually forgot something. I forgot to put the source of this picture. Okay? So going back, we have tangent theta is equal to the opposite all over adjacent. So once again, we put the tangent to the other side. We will have arc tangent of O all over A. Now we substitute. Remember that your O is what again? It's 3. And your adjacent is 4. So what will be the result? So arctangent 3 all over 4. This is once again approximately, wait, let me just erase this one. This is once again approximately 36.87 degrees. See, so far, these 3 basic trigonometric ratios have the same results. And we will do the same thing to the other trigonometric ratios. Okay? So now let me erase everything and rewrite the drawing here. So 5, 4, angle, and 3, 10. acute angle. So now let's go with cosecant theta. Okay? So here, cosecant theta is basically hypotenuse all over opposite. Now, if you're going to find the angle here, okay, we will have arc cosecant of h all over O. So if you have your calculator, you can now simply substitute your hypotenuse and opposite here in the inverse trigonometric function of cosecant. Okay? So remember your h is 5, your O is 3. So this is good. However, there's a problem because I told you before, there's no, I mean, commonly speaking, commonly or usually, there's no arc cosecant in your scientific calculator. Okay? So rather, what we're going to use is what? Okay? We're going to use, if you remember earlier, it's arc sine of 1 all over h all over O. Okay? We're going to use this one. So theta is equal to arc sine of 1 all over your h, 5 all over your O, 3. Okay, so that's it. Now you can simplify this one. So you have arc sine theta is arc sine of 3 all over 5. So this is the result. Okay. So approximately your angle, this would be 36.87. Alright, 36.87 degrees. Alright, so that's it. Right? See? Now we will do the same thing for your cosecant. Alright, we will do the same thing for your uh wait, no, this is 3. Wait. Okay. Anyways, let's go back. We will do the same thing to the other trigonometric functions. So let's try secant theta. Okay. So this is h all over a. So if you're going to find the angle here, you can put the second, we can put the second. Yeah, second to the right side. We will have arc secant of h all over a. However, again, commonly we do not know the equivalent of, we do not have the button for arcsecond in our scientific calculator. So we're going to use its equivalent, which is theta is equal to arc cosine of 1 all over h all over a. That's it. Okay, now we can substitute. So this is arc cosine of 1 all over 5 all over 4. So we can simplify this one. You will have arc cosine of 4 all over 5. And if you're going to get its uh, answer here, approximately, this is also 36.87 degrees. You see? Now, let's try the last one, which is cotangent theta. So for your cotangent theta, okay, we will have adjacent all over O. So to find the angle here, so you will have theta is equal to arc cotangent of A all over O. Now, we can get its equivalent, which is theta is equal to arc tangent of 1 all over A all over O. So this one we can now substitute. So arc tangent of 1 all over your A, it's 4, your O, it's 3. So what we will have is arc tangent of 3 all over 4. So this is also, if you're going to use the scientific calculator, this is approximately 36.87 degrees. And see? So to conclude, all uh, inverse trigonometric function should result in the same answer. Okay? For this case, okay, for this case, of course, okay? for this case. Like for example, what will be the angle here? And you're going to use any trigonometric ratio, or if you're going to apply all trigonometric ratio and you're going to get its inverse, the answer should all be the same. Okay? All right? The answer should all be the same. All right? Of course, if you're asking me, how about we find the angle here? Okay? Of course, what will be the angle here will not be the same as the angle here. Okay? They are not the same. All right? And if you're asking me how you find the angle here, then what do you call this one? You can apply what we've learned before. Okay? Like for example, if you want to find the angle here, you can apply any of the trigonometric sorry. Anyways, if you're going to find the angle here, okay, let me write the given once again. I mean, yeah, find the angle here. You can use any of the inverse trigonometric function, okay, as long as it is correct. Okay, I can use arc sine here. All right, so theta is equal to arc sine of opposite all over hypotenuse. What is your opposite here? This is 4. Because 4 is not beside with the theta, and your hypotenuse is 5. See? So you will have 4 all over 5. So this one, what we will have here, this is 4 all over 5. This is approximately 53.13 degrees. See? Earlier we have 36.87 degrees, right? Now here, in this case, this is 53.13 degrees. Okay? Can you try to experiment other trigonometric inverse trigonometric function for this? Yeah, you can. Okay, you can actually. All right, you can use arc secant, arc cosine, arc tangent. You can. And the answer is still the same. 53.13 degrees, at least by approximate. Okay? So here's the question. Can we use any trigonometric ratio for us to find the angle? Yes, you can. Just like what I told you. Like for example, earlier we found the angle, this one, which is 36.87 degrees, right? So we try the six trigonometric ratios and its inverse. So what happened? They result in the same thing, the same answer. So good. So yes, you can use any arc sine, arc cosine. It's up to you. All right? But of course, it depends on a given problem of right triangle. Okay? Like for example, okay, let's just say you have a right triangle and you have a given angle here. And then let's just say your hypotenuse is missing. Or your hypotenuse is missing. So what will be the angle here? Since you have the opposite, you have the adjacent, so what are you going to use? You're going to use what? Arctangent. Okay? Why? You can find the angle here by getting its opposite and its adjacent. Okay? So we will have arctangent of O all over A. Okay? So basically, first question, can we use any trigonometric ratio to get the angle? Yes. Second question though, uh, oh wait, no, there's no second question. That's the only question. So yeah, yes, you can use anything. But again, it depends on the given problem. Just like here, for example, you have 3 and 4, but you do not have your hypotenuse. So just use this one, okay? Or use arcotangent. Remember cotangent, right? It's A all over O. And its equivalent, it's arctangent of 1 all over A all over O, right? So yeah, you can use those, okay? Or you can do Pythagorean theorem, like you can find the missing side here, then it's up to you if you're going to use any trigonometric ratio. But if you're going to ask me which of the trigonometric ratio that are very important, not only in terms of finding the ratio, but also in finding the inverse. that would be arcsine. Arcsine, arccosine, and arctangent. These three. Okay, like for example, you want to find the missing angle. Well, just know these three inverse functions. These are like the very important trigonometric functions. Okay? So here, if for example, you have the missing angle here and we have your x and your y and your h, instead of just using other trigonometric ratios, just use these three basic trigonometric ratios and its inverse, which is arcsine, arccosine, and arctangent. All right? So, in other words, all right, to sum it up, the the usual case in finding the angle is with the use of these three, usually. All right? If you have the missing angle here, you can just use arcsine, or you can just use arccosine or arctangent. These are like the three basic inverse trigonometric function, and it is usually used. All right, it's usually used. They don't use uh, arcsecant, arccosecant, arctangent. Okay, this one is usually used in finding the angle. Okay, usually, right? Usually. So if you if you're not sure with arcsecant, arccosecant, or arcotangent, just know these three basic inverse trigonometric functions. Okay? At least if you knew these, there would be no more problem with you. All right? Because in finding the angle, I told you earlier, all of the inverse trigonometric functions should result in the same thing. Just like earlier, 36.87 degrees for arcsine, that's also the same thing for other inverse trigonometric function, 36.87 degrees. And I asked you guys if, I asked if should we use one of them? The answer is yes, right? So overall, it's okay if you're going to use any inverse trigonometric functions. It's totally okay. But usually, they use arcsine, arccosine, and arctangent, usually. Okay? So if you don't know arcsecant, arccosecant, arcotangent, just use that one. Okay? Just use arcsine theta, arccosine theta, and arctangent. These are, in fact, much better in finding the angle. Okay? Not only because these are basics, but they are far more convenient than the other three. And that will be all, guys. Right? So here, after this one, we will have a practice video, and we're going to discuss one more part, or I think two, which is about the properties of a trigonometric function. All right? So see you soon.